Before we move on to deriving the formula for the limiting sum, I want us to just think about what happens when I multiply small numbers together. Here I've taken just about the simplest small number there is, which is a half. What happens when I multiply a half times a half? Well, the answer to that is I get 1/4. And comparing this to what I started with, a quarter is less than what a half is. Okay. If I do the same thing, a half times a half times a half, that's going to be 1/8. That's even smaller again than the previous one. If you do a half times a half times a half times a half, this is 1/16, even smaller again. And this is I mean, it's kind of obvious that that's going to happen, but it's something that people miss because they're used to, when I multiply things together, I usually get something bigger than what I started with. So anytime you multiply two numbers that are bigger than 1 together, okay, 2 times 4, you'll get something that's bigger than either of the ones we started with. If you take two numbers that are less than 1 and you multiply them together, you get something less than what you started with. And this is worth knowing before we move on to finding the limiting sum formula. So let's have a look at our formula from before. Here we have the same series, 16, 8, 4, 2. We saw that the limiting sum for this was going to be 32, so we've got something to check with. If I take the sum to n terms, I'm going to make the substitution, and I'm going to make it without putting anything in for n just yet. So I'm going to have 1 minus a half to the power of n over 1 minus a half. Now I'll just tidy up as best I can. 16 times 1 is just 16. Minus, I'm going to have a half to the power of n, and this is going to be over 1/2. Now, what I can do here, I'm dividing by a fraction. Okay, that's just like dividing by a half is the same as multiplying by 2. So what I've actually got is 2 lots of 16 minus a half to the power of n. Now what I want us to think about is this little bit here. And think about it based on the information that I had before in the last slide that I looked at. If I take a half and I multiply it by itself, okay, I'm going to get a quarter. If I multiply it by a half again, I'm going to get an eighth. If I do it again, I'm going to get 16th, 1 out of 32, and so on. That's what this n's doing. Okay, it's multiplying a half by itself a bunch of times. What I'm asking is, what happens if n is a big number? Okay, and what I mean by big is like in the thousands, in the millions, in the billions. When it gets really big, this half to the power of n, okay, half multiplied by itself a bunch of times, it's going to keep getting smaller and smaller and smaller and smaller. When this gets really big, we say that the value of half to the n, it actually approaches 0. It becomes very, 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 very small. So small, in fact, that it's basically insignificant. So what I can do is the sum to infinity, it's going to be as if that doesn't exist. So it's actually going to turn into 2 times 16, which is 32. Okay? So the idea there is that as n becomes really big, this thing becomes insignificant. What we'll do is we'll formally derive this. Okay? So if I have my formula, Sn equals a outside of 1 minus r to the n on 1 minus r. Similarly, we've got that part here, okay, the common ratio times n. If, this is a big if r is less than 1, okay, then the sum to infinity is going to be as if this is 0. So r to the n becomes basically 0 as n approaches infinity. This becomes 1 minus 0. So my formula turns into 1 minus 0 is 1. I'm just going to get a on 1 minus r. And this is going to be my sum to infinity formula. Now when I put this here, I technically need to put that condition that I had over there. And I'm actually going to make a slight adjustment to that condition. It's actually not just if r is less than 1. It's actually if r is less than 1 and greater than negative 1. Okay, because remember r can be negative as well as positive. So theoretically if I had r as negative 1/2, this would also still hold. Negative 1/2 times itself a bunch of times is still going to be 0. So this is the condition. So this is the condition over here for when a limiting sum is allowed to be found, when it's going to approach a certain value and not get any closer. And this is how we find it using this formula, a over 1 minus r.